The second most application of the mole concept is in finding out the empirical formula and molecular formula of the compounds. See, empirical formula is the simplest ratio of various atoms present in the molecule of the compound. It is the simplest ratio of the various atoms which are present in the molecule of a compound. And then what is molecular formula is? It is the actual number of atoms of the different elements present in the one molecule of the compound. So let me write down for you the what is the molecular formula is. The molecular formula is the actual number of atoms of various elements present in one molecule of the compound. So it's the actual number of the atoms which are present, and empirical is the simplest ratio of the atoms which are present in the molecule of a compound. Let me write this in this form. Always remember the molecular formula is n times empirical formula. This n can be any whole number which is when multiplied by the empirical formula gives you the molecular formula. I can give you the example like if the empirical formula is CH2O, because the ratio of carbon hydrogen to oxygen is 1:2:1 and the N is 6, the molecular formula will be 6 times of CH2O. This comes out to be C6H12O6, which is your glucose or a fructose molecule. So this N is most important for us in finding out what is exactly the molecular formula is. And it is always what we say is the molecular formula is n times of the empirical formula, because empirical formula is the simplest ratio or the simplest number of the atoms present, and the molecular formula is the actual number of the atoms present. So there are always certain multiples. Now how to find out this n is, we know this n can be determined from a very basic formula, that it is always is a ratio of molecular mass or molar mass by empirical mass. Empirical mass is what? It is the mass of the formula, empirical formula. So if the empirical formula, the example we have taken here is like, let us take for C6H12O6, it is 12 6 is 72 plus 12 plus 16 18 into 66 will make it 180. So we know the molecular mass of this is its grams per mole. So molecular mass or molar mass of glucose is 180, and its empirical formula CH2O has 16, 17, 18, and this is what is yours? 12. So it is 30. It is 30 grams per mole. This is the empirical formula, empirical mass. So this is your empirical mass is, this is your molar mass is, and how to find out now this N is, it is 180 by 30, which gives you 6. So this is how we have got this 6. So this N is always is the ratio of the molecular mass over the empirical mass. Now let us understand how we can find out empirical formula and molecular formulas of the compound from a given numerical. The numerical is, a compound has hydrogen 4.1%, carbon 24.2%, and chlorine 74.6% by mass. If its molar mass is 98.6 grams per mole, find the empirical formula and molecular formula of the compound. So we are given the elements which are present in the compound in terms of their percentage composition. Molar mass is given to us and we have to find out both empirical and the molecular formulas. Now how this numerical is to be done? Let us see this. You must remember these percentage because I have to rub this out. See, we have hydrogen, we have carbon and we have chlorine. Their percentage given is 4.1, 24.2 and it was 74.6. If it is percentage by, since it was by mass, it means out of 100 grams, hydrogen is 4.1 grams, carbon is 24.2 grams and the chlorine is 74.6 grams. So how can we change this into number of moles? We know weight divided by atomic mass or molecular mass. So it will be 4.1 divided by 1, 24.2 divided by 12 and 74.6 divided by 35.5. This is going to give us the number of moles of these elements in the compound. Because we cannot convert mass into the number. First we know the moles. Moles can be converted into number. So it is approximately 4, it is approximately 2 and it is also approximately 2. Since these are already on their whole numbers, there is no need to divide them by any number so that we can have the simplest formula. We can have them exactly the simplest formula like, let's divide it by 2. So what we get is this as 1, this is as 2, this as 1 and this as 1. So what is the simplest ratio is 2:1:1. So this simplest ratio gives us the empirical formula, which is C1H2Cl1. Now from here we can find out empirical mass, which will be 12 of carbon, 2 of hydrogen and 35.5 of chlorine. So that makes it approximately 14 plus 35 is 49.5. This will be grams per mole. So we have calculated out the empirical formula, which is the simplest ratio. From here we have calculated the empirical mass and we were knowing, let me rub out this one, I think you all are knowing how to find it out. First we have converted it into the number of moles, then these number of moles are converted into their simplest ratio, and if we haven't got any these numbers in the whole ratio, we will change them into the next number by multiplying them with a simple number. So here by chance we have got them in the terms of 1, 1 and 2, so there is no need to do that. Now what we will do now is, we will find out N. The N we already know is the molecular mass or empirical mass. Molecular mass given was 98.6, empirical mass is 49.5, so this is approximately 2. When this N is 2, remember this molecular mass was given to us. So with this N is 2, your molecular formula, which is N times of your empirical formula, so it is twice of CH2Cl, so it will be C2H4Cl2. Now let us do one more numerical of empirical and molecular formulas. The numerical is, a gas is having carbon and hydrogen only On combustion, it gives 3.38 grams of CO2 and 0.69 grams of water. So how much of the gas has been taken? It hasn't been given. Only the mass of the CO2 obtained and the mass of the water obtained on burning that gas of carbon and hydrogen is given to us. 10 liter of the gas at STP weighs 11.6 grams. So definitely it means what? The molecular mass is also not given. It is given in the form of the volume of this gas, 10 liter, is occupying this or is having this much of mass. So we can find out molecular mass because we know if this 10 liters is weighing this much, 22.4 liters will weigh how much? Because 22.4 is 1 mole and mass of that will be the molecular mass or molar mass. So we can find out from this information. Then it asks, calculate empirical and molecular formula of the gas. So what we have to do in this is, see, everything is given actually in a hidden way. What is hidden is, the mass of the compound is not given, mass of the carbon is not given, mass of the hydrogen is not given, and the molar mass is not given. But first, what we will do is, we will use this information in finding out that how much of mass of carbon is there in the compound and how much of hydrogen is there in the compound. Because remember, whatever the carbon is there in this 3.38 grams of CO2 and whatever the hydrogen is there in 0.69 grams of hydrogen is all from that hydrocarbon gas. If we add those masses, that will give us the mass of the gas. From there we can find out the percentage composition of the carbon and hydrogen, and that can give us the empirical formula, from where we will find out empirical mass. Then we will use this information to find out molecular mass, that is going to give us the molecular formula. We know percentage of carbon in CO2 is 12 by 44 into 100. It is 27.27%. So, therefore, mass of carbon in 3.38 grams of CO2 will be how much? It will be 27.27 upon 100 into 3.38 grams. Because this much is the percentage of carbon in this, so out of 100 grams, if this is carbon is this much, out of 3.38 grams, it will be how much? So it is multiplied by 27.27 divided by 100. This gives us 0.912 grams. Similarly, percentage of hydrogen in water is 2 by 18 into 100, which is 11.11%. So therefore, mass of hydrogen in the numerical was having approximately 0.69 grams of water will be how much? We can find it out here. It will be 11.11% of 0.69 grams. So this comes out to be approximately 0.07 grams. So this much is the 76 जा सकते हैं, we can go, otherwise it is 0.076 or 7. So this much is the mass of hydrogen, and we have known that mass of carbon was coming out to be 0.912 grams. So now, therefore, the mass of gas taken is equal to mass of carbon plus mass of hydrogen. It came out to be 9.912 and it was 0.076. So this comes out to be 0.988 grams. Now therefore, percentage of carbon in gas is 0.912 upon 0.988 into 100. This comes out to be approximately 92%, 92.3%, and percentage of hydrogen in the gas will be 0.076 upon 0.988 into 100, which comes out to be 7.7%. Now, once we know the percentage compositions, let us do let us find out the number of moles and then the simplest ratio of carbon and hydrogen in the compound. The ratios are 92.3% and it is 7.7. How can we find out their number of moles? 92.3 divided by 12, 7.7 divided by 1. This is going to give us 7.7, 7.7 divide by 7.7, 7.7. So the simplest ratio is 1 and 1. So this 1 and 1 gives us the empirical formula is C1H1. Once we know the C1H1, therefore the empirical mass will be 12 plus 1, 13. And now let us do the calculation for molecular mass. 10 liters of gas at STP has mass of 11.6 grams. Therefore, 22.4 liters will have 11.6 divided by 10 into 22.4. This gives us approximately 26 grams per mole. So their molar mass is 22.26. So your N is molar mass over empirical mass. 26 by 13, it is 2. So once we know this N2, we know molecular formula is N times of empirical formula. It is 2 into CH, it is C2H2. So C2H2 is the gas acetylene or ethyne gas, which was actually there in this numerical, and whose the percentage compositions or the numerical was given like this.